So today I am going to start the real integrations with limits going from minus infinity to plus infinity. So the limit will be from minus infinity to plus infinity. That will be the limit, and we will do all the problems in which the limit will be from minus infinity to plus infinity. Okay, so let us start with that. The integrals will look like this. I told you about the different kind of real integrals that I am going to discuss. I have told you about that. So the integral will look like this. Integral minus infinity to plus infinity fx dx. Okay, so our function will look like this. So ये बात आपको हमेशा ध्यान रखना है कि जिस टाइप का इंटीग्रेशन डिस्कस कर रहे हैं फॉर्मूला उसी में अप्लाई करना है. वी हैव टू अप्लाई फॉर्मूला in that only. Okay, that means if I am telling you about this minus infinity to plus infinity case, then I can't apply the same formula for any other case. Okay, so this is case by case. This will be going case by case. So this is also a real integral, and the case is this. Now please see, uh, our known formula is for Cauchy integral theorem, and we have to use that Cauchy integral theorem very intelligently, like we did for 0 to 2 pi. So you can imagine that किसी ने तो वो guess किया होगा ना कि how to use that formula and calculate, how to use that Cauchy integral formula and calculate our real integrals. Okay, so how to get this minus infinity to plus infinity formula? So that will be trick number 2. Trick number 1 was what we did for 0 to 2 pi. Okay, so it goes like this. Suppose we make a semi contour like this, which has radius r, and this is semi contour. Okay, and seeing this function, I will write a function fz. So fz be a complex function. Okay, now apply that complex function to this. So what I am going to get is contour integration c fz dz is equal to 2 pi iota and sum of residues. Okay, where c is this semi contour that we have assumed. Semi contour. Now this contour is made up of, the initial thing is that real axis, so it will be fx dx, because when you will travel on the real axis, that means here on this whole line z is equal to x, because y is 0 here, and plus let me call this as c dash. This is complete closed contour, and this c is just a semi contour. Okay, c is just a semi contour. So write C dash here, which is a closed contour, and C is just semi contour. So it will be C Fz dz is equal to 2 pi I sum of residue. Please see this. Everything is okay? And now let us put the limit of R tending towards infinite to whole of this. This R and this R is different. Let me write here residue, not R. Huh? So limit R tending towards infinity will make this minus infinity to plus infinity. And when you will put the limit, what is the value of Z here? Z is equal to R e to the power I theta. You can see the semi contour. Z is equal to R e to the power I theta is the definition. So this will become fx dx plus, when you will put Z is equal to R e to the power I theta and you will put limit R tending towards infinity, this term will become 0. That is known as Jordan's lemma. After putting this limit, it becomes 0, and this will be equal to 2 pi I into sum of residue, and the residue will be calculated on all the poles inside this contour where R is the radius of the semicircle. R is the radius of the semicircle. So our formula simply became this is equal to 2 pi I sum of residue for this contour where R is infinity. I mean, this contour is very large on the upper side. So what will happen? All poles on the axis and upper half will be included ना, नीचे वाले तो बाहर चले जाएंगे. Upper half will be included because they are inside the contour. So your simple formula is this. So I have in a way derived that to just tell you how it is working.
Uh, Sir, how we can be sure that this contour when R tending to infinity?
How can we sure?
Contour when R tending towards infinity will become 0.
Contour
Contour
will
C.
not become, this function will,
Contour C. C, yes sir. Only
this
C.
function will become 0.
F Z D Z. How
Huh.
sir?
No, you have to calculate actually. You have to calculate the limit. You have to put Z is equal to R e to the power I theta and then you have to calculate the limit. But if 4 options are given, huh? So that means that has already gone to 0. Otherwise, we will not be able to calculate the integral. Na? Okay. So again, suppose the question is like this. The question is like this. We have to calculate the value of, suppose, an integral minus infinity to plus infinity sine of x upon x dx. Suppose we have to find out this value. Okay. Let me show you what is the meaning of this. If you take a graph like this, so sine x by x graph is going like this. So the meaning of this is we have to calculate area under the curve. Okay. So what will be that? So please pay attention. If I write fz and seeing this I will write fz, and if there is sine or cos I have to write e to the power iz, and for a algebraic number directly z, and for the answer I will take imaginary part of this. So now the answer will be integral minus infinity to plus infinity sin x by x dx will be imaginary part of sum of residue. That will be the answer. Okay. And what is the residue? So where is the pole? Pole is at z is equal to 0 for this semi contour. Pole is here. Okay. So I will write imaginary part of it is 2 pi I sum of residue, but I will write imaginary part of pi I into sum of residue because the pole is on the contour, na? It is on the real axis. It is on the real axis. So z is equal to 0 is a pole. What is the residue? Residue will be limit z tending towards 0 z fz. So that will be 1. So the answer will be imaginary part of pi I into 1, which is equal to pi. So answer is pi.
Sir, why you have written Z in replacement of X?
Why?
The X is the real part, X plus iota y we write as Z.
No. This was a question. Okay. And I explained you that how by writing some fz, suitable fz, I can calculate this integral. You remember this minus r to r and then c and then putting the limit of r tending towards infinity.
Infinity.
So how by writing a suitable fz and using Cauchy integral formula followed by what I have used in the derivation. Please see Cauchy integral formula. So that gives me integral minus infinity to plus infinity. समझ आ रहा है?
So I didn't get how you replace X by Z. I mean, sin X we can.
I have not replaced it. Please see the derivation of that, which I did. How that minus infinity to plus infinity sin x by x came. Please see that. In the derivation, how it came.
By addition.
Because you were moving on
by
the
addition of 2c plus.
No. Because you were moving on the real axis. So when you are moving from minus r to r, y is equal to 0. So that's why z became x.
Achha, okay, sir. Wow, yes, sir.
So, but
got it.
every time you need not to go into that derivation. अभी तो मैंने इतना भी कर दिया, इसको मैं बस एक लाइन में लिखता हूँ और एग्जाम में आपको भी वैसे ही करना है. ये नहीं कि सारा डेरिवेशन करना है बैठ के. ओके. सो किसी को कोई डाउट है तो पूछ लो. इसी बेसिस पे सारे क्वेश्चन लगने वाले हैं.
Excuse me, sir. Sir, integral minus infinity to infinity f of x ds, we have proved it as 2 pi I sigma residue, no, sir? Actually. But here, what we have written, sir, integral minus infinity to infinity sin x by x dx is equal to imaginary pi I, sir. 2 pi I, no, sir? Why we have written pi I, sir?
So again, you will have to go back to 3 or 4 classes. When I told you that when the pole lies on the contour,
yes, sir. Yes.
Then it will be its weightage will be halved.
Yes, sir. Yes, sir. Got it, sir. Okay, thank you, sir.
See, whatever you have learned till today, starting from the complex numbers, that will be used very, very frequently. I told you in the first class itself. No new concept I will be applying. whatever I teach, I use that in. अब अगर आप उसको रिवाइज नहीं करते हो तो फिर आपको लगेगा कि वो नया है, बट अदरवाइज कुछ भी नया नहीं होगा. Anybody else? Okay. So let me take another question. And this is actually a previous year question of NET. So integral minus infinity to plus infinity sine of 2x by x cube dx. This is the question. Now I'm not going to do anything. अब मैं बहुत जल्दी करूंगा. fz I will write e to the power I 2z by z cube for obvious reasons. Yes? Is that okay?
Yes.
And z is equal to 0 is a pole lying on the real axis. And what is the residue about this? So I can write it like this: 1 plus I 2z by 1 factorial plus I 2z square by 2 factorial plus dash 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 upon z cube. So what will be the value of b1? It will be minus 1, minus 2. Yes? Denominator is z cube. Okay. And answer will be pi I imaginary part of pi I into sum of residue minus 2. So answer will be minus 2 pi. This is the answer. Please say this. Yes? Any doubt?
No, sir.
Everybody?
Yes, sir. Yes, sir.
Now let us take next question. Integral minus infinity to plus infinity dx upon 1 plus x to the power 4 dx. This is the question. And fz will become 1 upon z to the power 4 plus 1. Again I will be using the same contour. Sorry?
सर 2 बार dx देते आप.
हाँ. Is that okay? So what about the poles? You will put z plus 1 is equal to 0. अब याद आया क्यों मैंने ये पहले ही पढ़ा दिया था आपको? So z to the power 4 will be minus 1, which will be equal to e to the power I 2n plus 1 pi. Yes? So z will be equal to e to the power I 2n plus 1 pi by 4. So what are the poles? Z0, which is 1, e to the power I, n is equal to 0 है ना, e to the power I pi by 4, which is actually 1 by root 2 plus iota 1 by root 2. Then Z1, which is e to the power I 3 pi by 4, which is second quadrant, minus 1 by 4 plus iota 1 by root 2. Z2, e to the power I 5 pi by 4, minus 1 by root 2 minus iota 1 by root 2. This all we have already done. And z3, the fourth root, e to the power I7 pi by 4, which will be 1 by root 2 minus iota 1 by root 2. Now please see this. This is our contour. This is imaginary axis. This is real axis. So whenever iota will be negative, it will go somewhere here below the contour. I mean, this will be minus minus. So somewhere here. Z2 will be somewhere here. Z3 will be somewhere here. Z1 will be here and Z0 will be here and Z1 will be here. इसीलिए मैंने आपको एरोगेंट प्लेन पे मार्क करना सिखाया था पहले दिन. First day I told you how to mark on the arrogant plane. Can you see that?
Yes, sir.
Now this and this lies inside and this goes outside, will not be considered. So our answer will be this time 2 pi I sum of residue, and residue will be calculated at Z0 and Z1. If you agree with this, I will erase this part, but quickly note it down. This is also a previous year question.
Two pi I because of including all the points.
So make
Because
good.
the poles are lies inside the contour.
Make good arguments. Don't make bad arguments. When I use 2 pi I, when I use pi I,
When the poles are in axis, on axis you use pi I, sir.
no,
On that.
I am asking Venkat.
Okay, sir. I got sir. Poles on the real axis.
So now see, we have to calculate residue on the Z0 and Z1 using this function. So I will use phi z by psi z, limit z tending towards Z0 first of all. Phi z by psi z will give me 1 upon 4 z cube. So it will become 1 by 4 e to the power minus 3 pi I by 4. And similarly, what about this? It will give me 1 by 4 e to the power minus 9 pi I by 4. Please check this. And now finally this 2 pi I, this plus this, e to the power minus 3 pi I by 4 plus minus 9 pi I by 4. This will become 2 pi I 1 by 4 and 3 pi second quadrant. So cos will be negative and sine will be negative, plus 9 pi by 4 means first quadrant. So it will be 1 by root 2 minus iota by root 2. So this will be cancelled. Okay. So this will become 2 1 2 2 to the 4, and what you will get is pi I by 2 into, from here you will get minus 2I by root 2. So iota minus 2 cancels, so it will become pi by root 2. This is the integers, value of integration. Check this. And which technique I have used to calculate the residue? Limit z tending towards Z0,
Pi x by psi dash.
pi z by psi dash z. And you all should remember quickly, I told you in first class, ASTC, you should be able to apply it quickly within no time. जैसे कि मैंने यहाँ अप्लाई कर दिया और ये देखते हुए कि यहाँ माइनस है तो cos ऑफ माइनस थीटा तो cos थीटा ही होता है, sin ऑफ माइनस थीटा इज माइनस sin थीटा. That I have used. So those +1 +2 mathematics is going hand in hand while calculation of all this. If there is any issue at any step, you can ask. बताओ भाई, कोई डाउट है? This is very nice question, and I hope you understood why we have calculated this in advance. So let me take another question. Minus infinity to plus infinity 2x upon 1 plus x square whole square dx. 2x, sorry, dx upon this. Tell me what will be fz. Now you start thinking about it. What is the value of fz?
dz upon 1 plus z square whole
No
square.
dz.
Yes.
So actually, I hope you understand what we are doing. Actually, we are calculating this integral. This value 1 upon, I am writing it by seeing here, and what I am doing actually, I have derived that. I will not be doing it again and again, but let me again tell you, it was like this. We have taken a contour like this. Contour is like substitution in an integral. Okay, so I am taking contour like this, and then what is going to happen, I will write this using Cauchy integral formula. I will write this contour integration c dash fz dz is equal to 2 pi I or pi I depending on where it is lying, but let me write it generally, 2 pi I sum of residue. Okay, this is the case, 2 pi I sum of residue. Now what we do is we break it like this, minus r and fx dx plus contour c fz dz, and that is equal to 2 pi I sum of residue. And then I put limit r tending towards infinity. So what will become? It will become minus infinity to plus infinity fx dx. This will be gone. I told you, you can see, you can calculate it for yourself, and this will be 2 pi I sum of residue with this contour, and this going like this contour is like this now in this limit. Okay, so all of the points above the real axis will be included, and on the real axis will be included, but below the real axis will be excluded. Okay, by this contour. So this is the method which I am using again and again. अब समझ आई बात? Tell me bhai, are you able to understand? This is what I am doing again and again for calculation of minus infinity to plus infinity integral. I am applying the same concept. Okay, so ये तो पहले ही पता है आपको, तो let me erase this and straightforward come to the point. This you already know. So what I will do is, I will first of all try to locate the poles, and they will be z plus iota square, z minus iota square. So if I locate them, iota will be here, minus iota will be here. So only iota is the pole. Okay. So what is the residue at z is equal to iota? This will be cancelled, and it will be d by dz of z plus iota minus 2. Huh? So it will be minus 2 z plus iota minus 3, and put z is equal to iota. So it will become minus 2 upon 2 iota cube. So it will become minus 1 by 4 plus 1 by 4 iota. Please see this. And what will be the answer? Answer will be 2 pi I into sum of residue. So 2i will give 2. So answer will be pi by 2. Answer will be pi by 2. एक बार ये क्वेश्चन भी अच्छे से देखो. अब देखो मैंने जो रेसिड्यू निकाला है, विद इन नो टाइम आपके लिए रेसिड्यू निकाल दिया है. यही तो हो रहा है ना? Without taking any time, I am calculating residue. That you have to do. Please check. किसी को कोई डाउट है तो इस क्वेश्चन में जरा पूछो. So I have immediately seen that pole is second order, and immediately I have applied the formula for second order. अब तो मैं differentiation वगैरह बहुत फटाफट किया है मैंने. ऐसे ही आपको भी करना है. You have to be also very quick without wasting time. Tell me. Now this is homework. Minus infinity to plus infinity dx upon 1 plus x to the power 6, and answer is 2 pi by 3. This is homework. इसमें कोई doubt? Can I erase this?
Yes, sir.
So देखो बिल्कुल सेम प्रिंसिपल लगा रहा हूं मैं. अब ऑब्वियसली आपको रेसिड्यू वगैरह निकालने में बिल्कुल स्मार्ट बनना है फटाफट, बिकॉज रेसिड्यू निकालना अभी हम नहीं सीख रहे हैं. अभी तो हम इंटीग्रल लगाने लगे ना. सो मैं मान के चल रहा हूं कि नाउ यू नो हाउ टू कैलकुलेट रेसिड्यू, but through every question we are learning the calculation of residue also, because I told you that in each and every question we will have to calculate residue. Now there is another integral that is known as Fourier integral, that I will teach you in Fourier transformation also. Suppose the integral is given like this: cos of sx by x square plus k square dx, and it is given that both s and k are positive. We have to find out this integration, and you will see that using contour integration it will become very easy to calculate this integration. Okay, fine. So let me do this quickly. So fz, please see this. F of z will become, f of z will become, now Venkat, see, and I will take which part of the answer? Real part, because I am writing it, and it is mandatory to write. Please remember, it is mandatory to write like this. I'm not going into the derivation of that. So remember that for cos and sine we have to go into e to the power and then take real or imaginary part accordingly. Okay, it is so easy question. E to the power I s z over z plus ik into z minus ik. I told you na, the Gauss factorization, how see that is working. And what are the poles? Z is equal to ik and minus ik. This will be rejected because if you make that semi-contour, ik will be here and minus ik will be here for this infinite radius semi-contour. Now we have to calculate the residue, which is a simple pole. So z tending towards ik. अब मैं पूरा फिर से लिख दे रहा हूं आपके लिए. E to the power I s z over z plus ik, z minus ik, it will be cancelled, and you put z is equal to ik, it will become e to the power I z ik over 2 ik. Okay, so now what will be my answer? It will be given by 2 pi I real of into e to the power minus sk over 2 ik. 2i 2i. So this whole is real. So it will become pi e to the power minus sk over k. That is answer. बोलो भाई. Any doubt? Any query?
Sir, here ik is on imaginary line and we have a circle which is of radius r. Sir, how can we say that it is less than r k ik?
Because your statement is wrong. We have a circle which is not of radius r now. We have a circle which has radius infinite.
Okay, sir. Okay, sir. Thanks.
See the figure.
Okay, sir.
So I told you poles के बारे में. Anything on the real axis or above the real axis will be included as a pole. For this case only, माइनस इंफिनिटी से प्लस इंफिनिटी में जो कंटूर बनाया है उसके लिए बात कर रहा हूं, नहीं तो आप सोचो कि कोई जनरल बात लिख रहा हूं मैं. आई एम नॉट राइटिंग एनीथिंग जर्नल. जनरल बात नहीं कर रहा. यस, ओके.
Yes, sir.
दिस इज क्लियर ना? एक बार जरा ध्यान से नोट कर लेना सब लोग. ये देखो, रियल पार्ट ऑफ दिस क्लियर. व्हाई रियल?
It is cos.
And please note down that side also. So you understood or not this minus infinity? And please see, in all of the cases here we have only even functions. हर केस में यहाँ even function था. Because यहाँ odd function का मतलब है answer is equal to 0. Okay, so whatever questions we have solved, in every case we had even function here. So I am stopping here. If you have any doubt you can ask, and then we will move to next cases in next class. Anything else you want to ask?
सर अगर कभी लिमिट अगर इनफिनिट नहीं है और कोई बिगर नंबर ले सकते हैं इसमें. लिमिट ऑफ इंटीग्रेशन जो है इन्फिनिटी
इंटीग्रेशन को ऐसे मत सीखो. जब तुमने 11th में सीखा था तो कैसे सीखा था बताओ जरा. इंटीग्रेट करना कैसे सीखा था? इस केस में ये कर लेते हैं, उस केस को ऐसे हैंडल, ऐसे तो सीखा था। हेलो,
हाँ सर सुन।
तो वैसे ही सीखना है, केस बाय केस। ये नहीं कि यहाँ पे लिमिट में इंफिनिटी ना हो तो, अरे
ना सर,
हाँ
नहीं वैसे नहीं बोल रहा मैं कि
हाँ
ये तो केस हो गई, लेकिन इसका कोई एप्लीकेशन है क्या कि मतलब जैसे कि इन्फिनिटी की जगह पे कोई फाइनाइट नंबर है लेकिन बिग है, तो जैसे कि कोई भी नंबर अगर मैं सोचूं एल माइनस एल टू प्लस एल, कुछ इस तरह का एप्लीकेशन हो सकता है क्या इसका,
हो
ऐसा पूछ
सकता
रहा
है,
हूँ।
बिल्कुल हो सकता है, बिल्कुल हो सकता है।
ठीक है।
बट अगर नंबर फाइनाइट है तो देयर आर अदर वेज आल्सो ना टू हैंडल दैट।
ओके।
न्यूमेरिकल टेक्निक है ऐसे तो उससे हैंडल कर सकते हो। सो देयर आर, इन प्रैक्टिकल सिचुएशन देयर आर मेनी वेज। दिस इज फॉर इंफिनिटी भी एक्चुअली लार्ज नंबर ही है ना। मान लो तुम्हारा यहाँ पे dx जो है वो मान लो 1 मिलीमीटर है और यहाँ पे -1 मिलियन मिलीमीटर है, तो इट इज जस्ट लाइक इंफिनिटी। उस सब चक्कर में मत पड़ो, पहले जो सिखाया जा रहा है उस पे फोकस करो, तो देखोगे एग्जाम में अरे ये तो ऐसे इसी वाले केस का आ गया, इसको फट से कर दिया। उस चीज के लिए काम कर रहे हैं हम। चलो लेट मी स्टॉप हियर, थैंक यू सो मच। फिर आई विल टेक दिस डिस्कशन फॉरवर्ड। सो देखो, रियल इंटीग्रेशन में पहला केस 0 to 2 पाई फिनिश, उसकी चीजें वहीं खत्म। ये नहीं उसमें z इज इक्वल टू ई टू द पावर आई थीटा माना था उसको यहां डालने लगो, वो वैसा हो जाएगा जैसे इंटीग्रल में यू मेक सम सब्स्टिट्यूशन एंड इंटीग्रेशन इज सॉल्व। सो डू कैन यू मेक दैट सब्स्टिट्यूशन इन ईच एंड एवरी क्वेश्चन? दैट विल नॉट वर्क। So, and this, the second one, minus infinity to plus infinity, where fx is even function, that we have handled. If it is odd, then answer is 0. Need not to do that. Okay. Then I will discuss some more questions in coming classes. Okay. Thank you so much.
Thank you, sir.